Gas lift is the method of artificial lift that uses an external source of high-pressure gas for supplementing formation gas to lift the well fluids. The primary consideration in the selection of a gas lift system to lift a well, a group of wells, or an entire field is the availability and compression cost of gas. Continuous ILO gas lift is the only method of artificial lift that fully utilizes the energy in the formation gas production. Most wells are gas lifted by continuous flow, which can be considered an extension of natural flow by supplementing the formation gas with additional high-pressure gas from an outside source. Gas is injected continuously into the production conduit at a maximum depth on the basis of the available injection gas pressure. The injection gas mixes with the produced well fluids and decreases the flowing pressure gradient of the mixture from the point of gas injection to the surface. The lower bowing pressure gradient reduces the flowing bottom hole pressure, BHFP, to establish the drawdown required for attaining a design production rate from the well. If sufficient drawdown in the bottom hole pressure, BHP, is not possible by continuous flow, intermittent gas lift operation may be used. Intermittent gas lift requires high instantaneous gas volumes to displace liquid slugs to the surface. The disadvantage of intermittent lift is an on-off need for high-pressure gas, which presents a gas handling problem at the surface and surging in the BHFP that cannot be tolerated in many wells producing sand. Most high-pressure gas lift systems are designed to recirculate the lift gas. The low-pressure gas from the production separator is compressed and re-injected into the well to lift the fluids from the well. This closed-loop, continuous flow gas lift operations are preferable with a closed rotative system. Intermittent gas lift operations are particularly difficult to regulate and to operate efficiently in smaller closed rotative systems with limited gas storage capacities in the low and high pressure lines. Applications: gas lift is particularly applicable for lifting wells where high pressure gas is available. Gas compressors may have been installed for gas injection, or high pressure gas wells may be nearby. Since the cost of compression far exceeds the cost of downhole gas lift equipment, gas lift always should be considered when an adequate volume of high-pressure gas is available for wells requiring artificial lift. Most wells can be depleted by gas lift, which is particularly true since the implementation of reservoir pressure maintenance programs in most major oil fields.